Section 2.5, Formulas and Problem Solving. Using formulas to solve problems. Sometimes you'll be asked to solve a problem using a pre-established formula in the sense you'll be asked to plug in the known variable into the formula to find the unknown variable. For instance, suppose you were given the variables where you knew the time and the rate of something, and that was related directly to distance. Well, you can use those variables to find the variable distance. See the next slide. Example, a family is planning their vacation to visit relatives. They will drive from Cincinnati, Ohio to Rapid City, South Dakota, a distance of 300 miles. They plan to average a rate of 50 miles per hour. How much time will they spend driving? Formula. Distance equals rate times time, or D equals R times T. What do we know? The distance from Ohio to South Dakota is 300 miles. The average rate of speed is 50 miles per hour. So D equals 300 miles and R equals 50 miles per hour. Here's a recap. Here's the formula. Here's what we know. Let's use what we know, plug into the formula to find the unknown. So D is 300. So where the D is, replace it with 300. Equals the rate which we will know is 5, which is 50. 50 times T. Now how am I going to solve for T? I need to get rid of the 50. I'm going to use a division property, which means I'm going to divide both sides by 50. On the right hand side, the 50s cancels out, leaving the T by itself, and 300 divided by 50 is 6. Therefore, this is translated to mean 6 hours. Another example. A wood deck is being built behind a house. The width of the deck must be 18 feet because of the shape of the house. If there is 450 square feet of deck material, find the length of the deck. What do we know? Here's the formula. Area equals length times width, or A equals L times W. What do we know? The width of the deck must be 18 feet. The square area of the deck is 450 square feet. Note, the term square area refers to area of a rectangle formula, basically area of a square, which is length times width. So here's a recap of what we know. Let's take what we know, plug into the formula, and solve for the unknown. So the area is given to be 450. We don't know the length, so I can't place anything in the place of L, but I do know the width, which is 18. Now how am I going to solve for L? Using the division property, divide both sides by 18. On the right hand side, the 18's cancel. 450 divided by 18 is 25 feet. Therefore, L equals 25 feet. Solving a formula for a variable. Sometimes you will be asked to use a pre-established formula to solve for a variable within the formula. You are doing what you've been doing as in the previous section, except for when doing this process, a variable tends to equal another variable instead of a variable equaling a number as seen in this previous section. See example on the next slide. Solve C equals 2 pi r for r. The question is asking you to get the r by itself. To do so, the 2 pi must be removed. To do this, we will divide both sides by 2 pi, which means if that is done on the right hand side, the 2 pi's will cancel out, leaving the r by itself, equaling c over 2 pi. Solve for L in the formula. V equals LWH. Well, in order to do this, that means that the WH needs to be removed. To do so, we'll use the division property, dividing both sides by WH, which means on the right hand side, the WH is canceled, leaving the L by itself, equaling V over WH. Solve P equals 2L plus 2W for L. Here, we need to get the L by itself, so every term that doesn't have an L on it needs to be moved away from every term that does. So to do this, we will subtract 2W from both sides of the equal sign. So on the right-hand side, the 2W's cancel out, leaving the 2L by itself, equaling P minus 2W. Now, how do we finally get the L by itself? Divide both sides by 2. On the right-hand side, the 2's cancel out, leaving the L by itself, and P minus 2W over 2 is our result. Section 2.7, linear inequalities and problem solving. Graphing inequalities on a number line. Graphing inequalities is not a difficult task. It involves finding solutions to the graph that will make the inequality a true statement. Remember to be careful of the inequality sign that is being used in the inequality. That sign will tell you the proper graph notation that will be used when graphing also. The direction to which the sign is pointing will tell you which direction the line will be drawn. See the next slide. Inequality graphing notation. Less than or greater than associates themselves with the open circle. And the less than or equal to and greater than or equal to associate themselves with the closed circle. Graph the inequality x is greater than or equal to -2. So here's your graph. Find -2, which is on the left-hand side of 0. Will we have an open or closed circle? It's going to be a closed circle because I have the greater than or equal to sign. So find -2, put a closed circle on -2. The direction of the inequality sign is pointing to the right. Therefore, we will draw the arrow to the right. Graph 5 is greater than x. Note, 5 is greater than x means the same as x is less than 5. Here, the problem was not changed. The inequality sign is still pointing to the x. We do this because you should read from the variable first. So therefore, rewriting the expression puts the variable on the left and puts the number on the right. So now that actually really truly says x is less than 5. So find 5, which is positive, which is on the right hand side of 0. We're going to have a open circle on 5. The direction of the arrow is pointing to the left. Therefore, we will draw the arrow to the left of 5. Recap again. Here's another example where here you have two compound inequalities being asked to graph at the same time. Okay, so this is very easily done. Be careful to note the inequality sign to which the number is beside. This will tell you where you will be using an open or closed circle on that number. -3 is beside the less than or equal to sign, and 1 is beside the less than sign. So here's your graph. Find -3, and you're going to have a closed circle on that as previously mentioned because of the sign it's beside. Find 1, which is on the right hand side of 0, and you're going to have an open circle on that, again because of the sign that it's beside. Now the shading or the arrow drawn will be between the two numbers. That is what it's meant when it says a compound inequality. The arrow is drawn in between the two numbers. Using the addition property to solve inequalities. Solving inequalities is a lot like solving normal equations. It too involves finding solutions to the graph that will make the inequality a true statement. Remember to be careful of the inequality sign that is being used in the inequality. See the next slide for examples. Solve the inequality x -6 is greater than or equal to -11, and then graph the solution. First step, solve it for x by adding 6 to both sides. On the left hand side, the 6's cancel, leaving the x by itself. Bring your inequality sign down. -11 being combined with 6, unlike signs, gives you a -5. Now let's graph that. Find -5, which is on the left hand side of 0. It's going to be a closed circle because of the inequality sign that's being used. The arrow is pointing to the right, so draw the arrow to the right. Another example. Subtract 8 on both sides to get the y by itself. The 8's cancel on the left, leaving the y by itself. Bring down your inequality sign. +11 combined with a -8, unlike sign, will give you a +3. Here's your graph. Find +3, which is on the right hand side of 0. Closed circle. The direction the arrow is pointing in is to the left, so therefore draw the arrow to the left. This again is a reiteration of what we just finished talking about. However, there is a very important rule here. And when multiplying or dividing inequalities by a negative number, the direction of the inequality sign will change. Please remember this. This is highly important when it comes to inequalities. First example, in order to solve for x here, we need to divide both sides by -3. Now the 3 is negative, so therefore, as I just mentioned that important note, I'm going to divide both sides by -3, which means the direction of the inequality sign will change. So therefore, x is now greater than or equal to positive 12 divided by -3, which is a -4. Here is your graph. Find -4, which is on the left-hand side of 0. Close circle. The direction of the arrow is now pointing to the right. So therefore, draw the arrow to the right. Here, we need to distribute first. So multiply everything in there by 4. I'm going to move the 4x to the left-hand side by subtracting 4x on both sides. Combining positive 2 with the -4, unlike signs, -2x, bring my -2 down, bring my inequality sign down, bring my -4 down. Add 2 to both sides. 2's cancel on the left. -2x is greater than the -4 combined with a positive 2. Unlike signs, subtract. Keep the sign on the larger number. Gives me -2. Solve for x by dividing both sides by -2. And because I'm dividing by -2, I have to remember to change the direction of the inequality sign. Therefore, x is now less than -2 divided by -2, which is positive 1. Here's my graph. Find positive 1, which is on the right-hand side of 0. Open circle. The arrow is now pointing to the left, so draw my arrow to the left.